For this scenario, we've been given the research question, the hypotheses, some information about our collected sample, as well as a distribution of sample statistics, and we're going to use all that information to answer some questions. So the research question is as follows. Is the average length of all the wires less than 4.2 inches? So we want to imagine we have a huge population of wires and we measure the length. If we were to measure the length of all the wires and then find the mean length of those wires, would that mean length be smaller than 4.2 inches? So we went out, we collect a sample, and the sample information is as follows. We collected a random sample of 78 of the wires. The average mean length of those 78 wires is 4.05 inches. All right, so the null and alternative hypothesis are written out for us already. Remember, the null hypothesis has to have an equal sign. The alternative hypothesis should match up with your research question, and it should have either a less than or a greater than or a not equal to symbol. So our null hypothesis is that the population mean mu is equal to 4.2, meaning the average length of all the wires is 4.2 inches. And the alternative hypothesis is that the population mean, is less than 4.2 inches. So the average length of the wires is less than 4.2 inches. So that's, remember, step one is to create your hypotheses. We then collected our sample, which is step two, and calculated the statistic. There it is. Step three is to create that distribution of sample statistics. So here we have a simulated distribution of sample statistics already given to us. It says in our simulation of sample statistics, the mean of the simulated distribution is 4.201. So right down the center of this, it's very close to mu equals 4.20. It says it's 4.201. And remember, that's because it's a simulation, and simulations tend to have a little bit off from that theoretical values. It tells us also that the standard deviation of this distribution is 0.036. So if we went up one standard deviation, and then we went up another one standard deviation so that we can clearly label 2 standard deviations higher and 2 standard deviations lower as well. We would then start at mu equals 4.201, and we'd add the value of the standard deviation, which is 0.036, and you'd get 4.237, which is 1 standard deviation higher, and 4.273, which is 2 standard deviations higher. Anything higher than that, any statistic you got that was higher than 4.273 would be considered unusually high. And if you went downwards, 1 standard deviation below the mean is 4.165, 2 standard deviations below the mean is 4.129. Anything lower than that, any statistic we got lower than that would be considered unusually low. All right, so it says in part A to please identify the sample statistic. So the sample statistic, they said, was that when we collected 78 wires, those 78 wires had an average mean length of 4.05. That is a sample mean, so that is an X bar. X bar equals 4.05 inches in our sample. Part B says to identify the assumption that was made to create the simulated distribution of sample statistics. So remember, step 2 of our hypothesis testing process is to write the null and alternative hypothesis, and step 3 is to assume the null hypothesis is true and use that assumption to create the distribution of sample statistics. So in this case, our null hypothesis is that the average length of all the wires is 4.2 inches. That is what we are assuming to be true when we create that distribution. We assume that the average length of all wires is 4.2 inches, and we used that assumption to create the distribution of sample statistics. Based on that assumption, we would get sample statistics that have this normally shaped distribution to them, with many sample statistics near 4.2 inches, some higher, some lower. Very few sample statistics would be unusually higher than 4.2 inches, and very few would be unusually lower than 4.2 inches. That's what we're seeing in that distribution. And then it says use the standard deviation rule, the two standard deviation rule, to describe which sample statistics are usual and expected versus those that are unusual, unexpected. We already labeled that up above. So sample statistics that are higher than 4.273 inches or lower than 4.129 inches would be considered unusually high or unusually low if it's true that the true population mean is 4.201 inches. So those statistics that are in between those two values would be considered usual and expected sorts of statistics to get if the true population mean is 4.201 inches. And so now we make a conclusion. To make our conclusion, we need to identify where our actual observed statistic falls on this distribution. So our actual observed statistic is 4.05 inches. Now notice 4.05 inches definitely falls down here in the realm of unusually low. It's 4.05, which is down below 4.129. It's in that realm of unusually low statistics. So our observed statistic is unusually low if it is actually true that the population of all wires has an average length of 4.2 inches. So since our observed statistic is unusual, our conclusion is that we have strong evidence that the population mean is actually lower than 4.2 inches. So notice that means we're supporting the alternative hypothesis.